We want an area of the loop of the curve defined by r squared equals 9 cos 2 theta. So we'll do a little sketch of this first of all. See what we get. First of all, when we put theta as naught in, cos naught is 1, r squared is 9. So at naught, when you have r squared equals 9, you'll get two values for r, 3 and minus 3. So that's the first value. Let's go around this way to have a look at it first. And then when this is going to be naught is the interesting thing, and it's going to be naught when the angle is 45 degrees, isn't it, or pi over 4? Because 2 lots of 45 is 90, and cos 90 is naught. So 9 times naught is naught. R squared equals naught. Square root, you still get naught. So you can see, I hope, that these values come around and they go to 0 at pi over 4. So this is like half of the loop, isn't it? And there's symmetry with the cosine. When you square root this, you'll get plus or minus, of course. So you're going to get the same thing coming in here. But you've got that generated, and then you're going to get, when you do from pi over, if you do the, because it's, what is it, symmetric, around this axis, you're going to have generated this part here from minus pi over 4 to naught. So that's easy to put in. So there's our loop that we want, isn't it? And we've just seen that an area of this loop is from 0 to pi over 4. If I do two lots of that upper half, that will be easy, won't it? So here, let's use a thicker pen. So here then, the area is equal to a half integral r squared. Now we're going from 0 to pi over 4 for this area in question, d theta. This doesn't arise because we're dealing with r squared when we work out the area, so all we'll get is this segment here. So that's what we're going to get. And we want two lots of it, don't we, to get the other half as well, because there's symmetry. And that will give us one complete loop here. So that's equal to then is the integral between 0 and pi over 4 of r squared. Now we've already got r squared. It's 9 cos 2 theta. So that's an easy mistake to make, to start to square this, which we don't need to do in this instance because we've got the loop, the polar curve defined in this form, which is already r squared. So integral cos is sine. We'll need a 2 underneath. We've got sine 2 theta between 0 and pi over 4. Top value take bottom value then, and 9 over 2 can come outside the bracket. Top value will be sine of 2 lots of pi over 4, which is pi over 2. Sine pi over 2 is 1. Take away bottom value, put 0 in, sine 0 is 0. So it's 9 over 2. Which, if you think about it, this is this whole area here now is like a shape with a maximum diameter of 3. The circle will be pi r squared. So that doesn't look too far off. This is squashed, of course. Pi r squared, yeah. Not too bad. That doesn't look too bad at all. So I think that looks okay.